All right, welcome back to Workshop Wasteland. Today we are going to machine these end bells for this PM Research generator, or Dynamo as they call it. We left off the last video with a nearly finished machine casting. We got to drill some holes to mount these end bells, as well as the mounting holes in the bottom for the foot and the top. I'm going to wait to drill the holes here in the ends until we get these things finished machined, get them on here like this, and then we'll transfer punch the holes. I think that's going to work the best. So let me give you a little bit closer look at what we have to do today. Let you take a peek at the plans, and we'll go from there. So for these end bells, they're two different parts. This is the deeper one, which is this end right here, which will house the brushes. We're going to start with what I'm going to say is probably the easier one. That's the bell right there. As you can see, pretty basic facing operation. And then the kit includes these little bronze of some sort. Maybe they're like oil light bushings, but you got to bore a 1/4 inch hole for those. So let me get you set up on the lathe, and we'll see what we can do. This probably isn't the most ideal setup in the whole world, but this is sort of an awkward part to hold, and I think we're going to get away with this. I'm going to put an indicator here on the front. We got a big nub sticking out, as you can see on the casting here. Get you a little bit better shot. You can see where they cut that off, some sort of a casting sprue or something like that. So we're on that side of it right now. As you can see, the indicator's on 0. Spin it around as far as I can here. And we're within a 1/2 thou there, so that's probably good enough. Let me throw an indicator down here on the center of the bore where we're going to be machining, and we'll see if that's running fairly true as well, which I suspect is probably not bad. All right, got the indicator over here running on the top surface. It's definitely not as good as I wish it was. I might try and tap around at it a little bit, but this is not an independent 4-jaw chuck, so I really can't move this around much. So I think maybe we just live with this. I think it's probably good enough. Keep in mind the needle's going to jump a lot when it goes over those little nubs for the little screw bosses. But as you can see, we're coming down to about 13 there. About 7 thou there. About 7 thou. I actually think it's pretty good. I think there might be a bit of a high spot right there in this sector of the piece, because everything else is much closer. I don't know. I think we'll at least get this faced off, and then maybe take a shortcut here, short of our dimensions, and see how it looks. Centered up back and forth on our piece. I think it's probably going to be all right, but let's take a cut and see how it looks. Going to be using this tangential tool holder that I made a video about. We'll see how it does. Bit of an interrupted cut to start. Get rid of this nub. That'll be a good test to see if this setup's going to hold too, so that's not so bad. Got that rough faced off. I'm going to get my eye down here and look at it as it spins and see what it looks like. Slow the lathe down here and get you a look too. definitely see a bit of run out in it, so I may have to try and move that around a bit in the jaws. As you can see, the part definitely has some run out here. I mean, it's not terrible, but it's also not great. So I think we may have to come up with something different here on this. Off camera, I took a really light cut until it was a full cleanup with my boring bar right here. And then I took calipers and measured the thickness all the way around the circle. And it's actually really good. So I discovered that there's actually kind of a bad spot in the casting. See if I can get you zoomed in on that so you can see. Let me just pop my phone out of here real quick. Yeah, so there's sort of a bad spot in the casting right there, and it really gave it an optical illusion that it was much worse than what it is. So if I spin this up real quick, you'll see what I'm saying. It's actually not bad at all for run out. I know that that's now a machined surface, so of course it looks better than what it could have been, because obviously I machined it concentrically now, but it's going to be fine. Really, this is only cosmetic, right? Whenever it slides onto here, you don't want this to be way off to one side or the other. So it's only cosmetic because we're going to bore this step on here like the plan showed, and then in the same setup, we're going to punch a hole in the center and use a reamer to ream it for that bushing. So it's still going to be centered up in the casting because the step's going to force it to be centered in here, and then the bushing is going to keep the rotor of the motor centered up as well. So realistically, it doesn't matter that much besides pure aesthetics, and as long as we can get to being able to put our bolts into the casting, which we will. It might be a few thou out, but it's definitely not enough to lose any sleep over. So let's continue on. The plans call for the overall thickness of this to be 0.156, 175 or so. So I took a facing cut off of here, put my indicator, as you can see over here, up against my carriage on 0. Let's take a 10 thou depth of cut, which is very light. I could definitely take more, but we're going to err on the side of caution here. Lock down my carriage and take a cleanup cut on this. Take another measurement here, see where we're at. 160, 165, 165. Yeah, so it might be a little crooked in there, but we should be just fine. So 156, I'm going to take 5 thou more off, call that good. Do a quick cut on this and be right back. So the plans call for a 1/32 deep step, and then the internal bore of, or the internal diameter of 1.332. So let's work on that. 1/32 deep. So 1/32 is 31 thousandths. Re-zeroed my indicator over here, and I'm gonna go in 20 thou to give myself a cleanup cut. I'm actually gonna go 25 thousandths, leave myself a 5 thou cleanup cut at the end, and we need to come into 1.332. So let's sneak up on that, take a bit of a cut here, see where we're at, and then we can adjust from there. So I can leave my setup as is, right? I got my indicator over here for my depth stop, and I'm not going to move my carriage at all. So I can back out of my cut, and then with calipers, we can get a measurement here and see how far off we actually are. Looks like we're at about 1590, so we got a good little ways to go here. So I'm going to come back in now over here on my indicator to my 25 thou mark, which is right there. So we need 1332 and we have 1590. Let me do some math off camera real fast. So maybe it's just me, but I like to write everything out. Obviously I could have done that basic math on a calculator, but I just feel like, you know, your mind stays sharper if you utilize it more often. We're just surrounded by technology constantly. So 1.590 minus 1.332 gives us 258. Now what that means is we have to take 258 off of here, but on a lathe you're effectively cutting off all sides of the part. So whatever you dial in back here on the compound, or I'm sorry, on your cross slide, is effectively doubled, at least on this lathe. So if we dial in 100 thousandths here, we actually took off 200 thousandths. So that's what I'm going to do. I'm going to come in 100 thousandths, and then we're going to remeasure and kind of see where we're at, see how accurate we're doing. So right now we're on 45. I'm going to come back to 45. All right, now once again we can back out because we can come back to our cut. Take another measurement here. And we are at about 1.4. So at this point, we can use our part as well, right? We can make sure that it's going to fit. Now, obviously, this isn't going to fit yet, right? But we can use this as kind of a go, no-go gauge and sneak up on that dimension. Move back in my 25 on my dial indicator. Let's take off 10 thou more and see where we're at. So as I said before, there's no reason to rush on this. Take your time, do it right. That way you only have to do it once. If you were getting paid for this and, you know, it was a high production machine shop, then by all means, you'd be needing to kind of rush through this. But I can take my time and do what we need to do here. Looks like we're at 382. So we need to take off about 50 thou more. So let's go ahead and take off another 10. And again, dialing in 10 on my cross slide is actually taking off 20 thou from the part. So that's just something you got to keep in mind whenever you're starting out. We're holding pretty true, 62 thousandths. So we need to take off 30 more. I'm going to take 10 more. Again, I'll do this off camera and I'll get you down to where we are with the final dimension. So I'm at 1.332 and we got a really nice fit on this. So that's perfect. That's what we needed to do. But we were only at 25 thousandths deep and we had to go to 31 thousandths, which, because of setting up a dial indicator, is easy to do. So let's do that. Alright, all that's left now is to drill and bore our hole in the center. Get my carriage out of the way a little bit more here. I have a center drill set up in a end mill holder with an MT2 taper, which is what my tailstock is. And I like that because it's really rigid. So I'm going to poke this center drill in. Our bushing measures 252 thousandths, which will give us a nice press fit with a 1/4 inch reamer. So this is a letter C drill, which should drill 242, and I'm going to come back with the reamer. Quarter inch reamer shouldn't take too much out of this hole. Hit this real quick with the deburring tool. Get rid of that sharp edge if there is one. Now, got our little bushing here. In my experience, these cheap Amazon reamers that I use are usually a little bit oversized. I should have got undersized reamers. That feels like it's going to be perfect, actually. So worst case scenario, throw a little bit of Loctite on this and be good to go. So that should complete this part, at least for the lathe side of things. Try a little bit harder to get this one dialed in better. We're within a couple thou here, which I think is pretty darn good, considering it's a rough casting. But this is a half thou indicator, so between the 10 and the 5 is only 5 thousandths. I'd say we're within about 3 on the inside, which is not bad at all. Now I'll put an indicator on this face and see how far out we are there. As you can see, I'm clamping this in a bigger 4-jaw chuck. Probably not the absolute best setup, but I believe we're going to get away with it. This is aluminum, and we only have to take light cuts. It's not like we have to hog off a ton of material. So let's see what we can do here on the face of this part, which again is a rough casting. Face is about 6 thou out, so we're twice again as good as we were on the other one. I think we call this good to go. Really looks like about 5.5 thou out. So that's probably pretty darn good. I don't want to tap around on this too much, it only being aluminum, and it's currently clamped snug in the 4-jaw. I'm afraid if we start pounding on it, we're probably going to break it, and I don't want to break it. So again, we're going to cut the lip, or the step, whatever you want to call it, and then bore the hole in the center on the same setup. So in theory, everything will be good to go. So this was a rinse and repeat on this side. We got a really nice fit here with our casting, which is awesome. The only difference on this one, we have to bore out the center to make some clearance for the brushes, and then we got to bore it to a depth of 476, and looks like 1.188. So we'll get that bored out, and that'll be it for this piece minus the mounting holes. So let me get set up here to do this cut, and we'll see how that goes. Try and get you a good shot of the boring operation here. Like I said, this bore needs to go to a depth of 476 and a diameter of 1.188. So let's run in there for a cleanup cut down to our depth of 476 and see where we're at. come out and touch. $476. Right there. This diameter is supposed to be 1.188. See where we're at here to start with. Oh shoot, we're almost dead on. Good thing I didn't take any more. Looks like we have to take about 5 thou out of there, so we'll dial in about 2. That should get us very close to our final dimension. Like I said, luckily I didn't take any more than that. That would have sucked. I'm going to come across the bottom and clean up the bottom. Boring bars don't do a great job of this, but it'll be good enough for this operation. Yeah, that cleaned the bottom up pretty good. Good enough anyways. Let's see, 1.188. 89. Yeah, 88. Looks good. That's finished as far as we can go in the lathe, so the next operation will be drilling the holes. Quick little test assembly and a piece of 1/4 inch drill rod. Fits nice and snug in our bored holes and has no problem sliding through, so I think we got away with the mistake that we made here on this end. As you can see, there's more of the casting on this side than there is this side, but I believe it's purely cosmetic. However, this side's much better. Taking that extra time to dial that in with the 4-jaw was worth it. That's much better. Next operation, let's go through and drill our mounting holes, which we'll do over on the mill. Set up here on the mill. Got the foot of this assembly clamped against the fixed jaw, small V-block, and it's sitting down on the bottom of the vise, which should be parallel. I already indicated this side. It's about the same as we have here, about a 1/2 thou to a thou off, which is more than acceptable. So we'll get set up and get our end bell nice and square where we want it, and then find the center, and then we're going to use the DRO to drill these holes, providing they all look nice and square and centered and all of that. So let me get you set up in the tripod here and show you what we're going to do. This is my setup to lay out these 4 holes on my milling machine, which I happen to have a DRO on, so might as well utilize the bolt circle function. So I got a piece of 1/4 inch. In this case, it's a 1/4 inch center drill. I can come down into our hole no problem, so I know I'm centered up on, you know, the middle of the part, which is how the bolt circle starts. Over here on the plans, it says 4 holes equally spaced on a 1.562 diameter bolt circle, but my bolt circle function works off of radius. So to find the radius, of course, divide the diameter by 2, which gives us 781. We're going to drill 4 holes, and I'll show you why I wrote down 45 degrees. If you can imagine a circle 360 degrees, say my finger is 0, then that means over here is 90. but I want to be in between 0 and 90, so half of that is 45. I already laid out a bolt circle, but to show you how this would work, you would do your 781 for the radius, as it says right there. Next is number of holes, that's going to be 4. And then angle A, if you look at the picture right here, it shows you the A, which is where the first hole is going to start. So in this case, it's 45 degrees. And you would create this. I already have it created, so I'm not gonna actually create it, but you get the idea. So then whenever I come over here to my bolt circle, number 1, I now have coordinates to number 1. Negative 552 off of our center location in both the X and the Y. Let me show you what that looks like down here on the mill. So we have to go both directions, 552. Crank over here, 552. I can't show you the DRO and the part at the same time. I only have one camera. So you have to just take my word on it. But we go to 0, 0 on the X and the Y because we're zeroing on our point that we created. 0, 0, we come down and touch, and it gets us in the center of that boss. Now what I'll do is come over to my next circle, touch off over there, get it the way I want it, and then I'm going to clamp this down so it can't turn once we start drilling. And I'm going to drill and tap one at a time because that'll ensure we don't lose our concentricity as we go. So let me get this finished set up and clamped, and then we'll go from there. Move back to the next hole location. Everything looks good, so I think I have this turned pretty well square. I also threw a machinist square up here and squared off of my vise here, and it looks square across here as well. So I think we're pretty good. I'm going to just go ahead and drill it, and I'll keep an eye on as we're drilling all of these, make sure we're pretty well centered on those bosses that they have cast into that end bell. All right, so I put a center dimple on this hole, and I got a center drill in that hole. It's not absolutely perfect, but it's pretty darn close. So these are 348 threaded holes. For a 348, you use a number 47 drill, and the plans say to drill 5/16 deep into the casting. So 5/16 is 312 thousandths. I'm probably going to drill a little bit deeper than that just to give some clearance for the tap whenever I tap this, but of course we're going to start the measurement after we get through the aluminum. The setup here is not the best. As you can see, got one hole down on this side, but all I'm doing is keeping this from turning. So in all reality, this is just fine. All right, let's go ahead and drill this. So I'm getting cast iron dust there. I'm going to zero my Z-axis on that. And then, like I said, the plans call for 312 thousandths, but we're probably going to go to about, I don't know, probably drill 3/8 of an inch, which is 375. Next thing we need to do is drill our clearance hole for a 348, which is a number 41 drill. So we'll drill this out with a number 41 through this aluminum. give a quick check, make sure our screw fits, which it does, so that's great. Set up for the tapping. This is one of those spring-loaded tap followers. It helps to keep things squared up, especially with these little tiny taps. 348 is super small. So I didn't move the X or the Y at all for drilling this hole. And I'm going to run this in until we're bottomed out. And we'll rinse and repeat 7 more times. Hope you enjoyed this part 2 of this dynamo build. Few small pieces to make yet. We have to create the eyelet, which is here for the top, which would be to scale like a lifting eye. And it's also going to be a support for this center bushing, which keeps the magnets on this pushed out at the top. That's a super easy lathe operation to do with this. Nothing to that. The eyelet may be a little bit more complicated, but we'll get through it. And then looks like 2 little binding posts for the wires, and that's about it. We'll have an operational dynamo. If you enjoyed the video, please like, comment, subscribe, maybe share with your friends. It would help the channel out tremendously. Otherwise, until the next video, have a wonderful night.